So it is x of k. So it is equal to the summation n is equal to 0 to the n minus 1 x of n into omega n to the power of kn. So here k can take the value from 0 is less than k is less than or equal to the n minus 1. So here we have written the formula which is called as the Twiddle factor. Let us introduce some of the properties of the Twiddle factor. So we have the Twiddle factor. So that is given by, so it is it equal to the omega into the power of kn. So it is nothing but e to the power of minus j 2 pi k into n divided by n. So this is a Twiddle factor which is going to be its exponential function. So it is going to satisfy one of the property which is called as the periodicity property. It is going to satisfy. So the periodicity property of the Twiddle factor is given by like this. So it is the periodicity property. What it says is, suppose if I'm having a Twiddle factor which is nothing but omega n to the power of a, and since it's a periodic with the period n, we can say like this: omega into the power of a plus n is equal to the omega into the power of a. So this is called as the periodicity property of the Twiddle factor. So which one? Let us find out the periodicity property, because it's very important. Characteristics of the periodicity property is very important. So we are going to apply this property in the fast Fourier transform in order to find, in order to reduce the number of calculations. Let us consider the LHS part of the Twiddle factor. So this LHS part I am going to consider omega n to the power of a plus n we are going to consider. So I am going to, in order to prove this property, we are going to convert the Twiddle factor in terms of the exponential term. We are going to convert like this. This is exponential form where we are going to represent the Twiddle factor. We are going to convert into that form. So it is, it can be expressed as e to the power of minus, so omega n is nothing but e to the power of minus j 2 pi divided by n, and a plus n is there. So I'm going to rewrite that as a plus n we are going to write. Now by applying the exponential power of indices, we can express like this: e to the power of minus j 2 pi divided by n into a. So into, I'm going to apply the law of indices. So it is e to the power of minus j 2 pi divided by a, that is n into n we are going to have here. So here, since we have the two n's are there, the numerator and denominator, it's going to get cancelled. So the remaining quantity is nothing but, so it will be equal to the, this is exponential e to the power of minus j 2 pi divided by capital N into a, into the remaining quantity is e to the power of minus j 2 pi. So now let us find out what is the value for the exponential term e to the power of minus j 2 pi. So e to the power of minus j 2 pi. So this let us convert in terms of the by using convert in terms of the cos and sine function. We know that e to the power of minus j theta is nothing but it's a cos theta minus j sine theta. So let us convert like this here. So it is cos into 2 pi minus j sine 2 pi minus j sine 2 pi. So cos 2 pi is nothing but it is nothing but cos 0. So this value is equal to the, so it is equal to 1, and sine 2 pi is nothing but it's a sine 0. This value will be equal to 0. So we can get e to the power of minus j 2 pi is equal to the 1 here. So this is one of the property we are going to use. So e to the power of minus j 2 pi, this value will be equal to the 1. Let us substitute in place of here. So the LHS will become equal to the LHS part will become equal to the, so e to the power of minus j 2 pi divided by n into capital A, sorry, small a into 1 will get. So if you convert this into the exponential form, it will become, so omega n to the power of a will get. So which is equal to the RHS part. So the Twiddle factor, what are the Twiddle factor we are consider? It is going to satisfy the periodicity property. That is, it is periodic with the period equal to the omega n to the power of a plus n is equal to the omega n to the power of a, and it is periodic with the period equal to the, so the period value will be equal to the capital N. That's a fundamental period, or that's a periodicity of the Twiddle factor. So this property is having a many advantages is there. So because of the periodicity property of omega n, the sequence x of n and x of k, so both are going to exhibit the periodicity property. It is going to exhibit because of this one. That one you are going to call it as a implicit periodic functions. You are going to call implicit periodic functions. Let us look how the Twiddle factor is going to exhibit the periodicity property. Let us look into that one. So I'm going to take the example of n value I'm going to consider. Let us take n is equal to certain value 4 will take here. So we'll consider the value of n is equal to the 4 will consider. So just I'll scroll down. Let us consider the value of n is equal to the 4 will consider. So I'll take, let us take the example. Let us take the example of n is equal to the 4 will consider. So this will become omega 4 to the power of a will become. So here omega 4 to the power of a. So here a can take the value 0 is less than a is less than or equal to the n minus 1. So since the value of n is equal to 4, we can take a can take the value 0 is less than or equal to a is less than or equal to the 3 it will take here. Means after the 4, the after the sequence that is 0 to the 3, the sequence is going to be repeated here. Now I'm going to represent the Twiddle factor on the circle I'm going to represent. Let us take this a is equal to 0, a is equal to 1, a is equal to 2, and a is equal to 3. So if I substitute a is equal to 4, so this will become equal to the a is equal to 4, and this is also equal to the 5, and this is also equal to the 6, and this is also equal to the 7 by applying the periodicity property. Let me check verify mathematically by using the this one here. Okay, so we have omega n value is nothing but 4 to the power of a plus 4 is it. So this one is nothing but omega 4 to the power of a, omega 4 to the power of a. So if I substitute a is equal to, for example, 4 here, if I substitute a is equal to 4, so this is nothing but that is if I substitute, I want to find out the omega 4 to the power of 4, this is the value of a here, 4 to the power of 4, we can express as like this. So omega 4 to the power of 4, by applying this one we can express as a omega 4 to the power of 0 plus 4. So this is also nothing but omega 4 to the power of 4, that is by using the periodicity property. So we can say that after the periodicity of n, so this will become equal to the the same sequence is going to be repeated here. So similarly, if I want to find out omega 4 to the power of 7, so I can express like this. Omega 4 to the power of 7 can be expressed as, I'm going to split the 7 as, so 3 plus 4 I'm going to split here. So this is equal to the omega 4 to the power of 3 here. So after the fundamental period of 4, the signal is going to be repeated here. So this is one of the property which is called as the periodicity property of the Twiddle factor we are going to consider. And also the Twiddle factor is going to satisfy, I'll take the example of one more sequence I'll take here. One more sequence I'm going to take. Let us take n is equal to the something called, let us take n is equal to the value of 8 we'll consider. So this is nothing but a can take the value from 0 is less than a is less than 7 it will take. So it is can be represented as omega 8 to the power of a we can represent. So in terms of the circle, I'm going to have the 8 points will be there. So this is a is equal to 0, 1, 2, and this is the 3, and this is 4, 5, 6, and this is 7 here. So this is the in the clockwise direction we can take like this. The value of a in the clockwise direction will be taken. And if I want to find out in the anti-clockwise direction, we should take this. It will take the negative values will be taken. So in the clockwise direction, the positive values will be taken. In the anti-clockwise direction, the negative values will be taken here. For example, if I want to find the value for the omega 8 to the power of minus 2, if I want to find out here. So in order to find out, again, I'm going to use the same periodicity property I'm going to use. So this one I can express as omega 8 to the power of minus 2. Let us add the value of n to this one here. So if I'm going to add n to this one, so it will become omega 8 to the power of 8 minus 2 will become equal to the 6 here. So like this, if I go in the anti-clockwise direction here, so here you can see this is n is equal to 0, this is n is equal to minus 1. So this is minus 2, minus 3, and this is n is equal to the minus 4, and this is minus 5, and this is minus 6, and this is equal to the minus 7. So as we see, omega 8 to the power of minus 2 is also equal to the 6 here, and omega 8 to the power of, similarly we can find out the rest of the values, omega 8 to the power of minus 3. So this is also can be taken as minus 3 plus 8, which will be equal to the omega 8 to the power of 5 here. So this is same as what we have find out here. So in the anti-clockwise direction, the negative values will be taken here, and in the clockwise direction, the positive values will be taken. So this is the one of the important property of the Twiddle factor. So which is going to be considered in the clockwise as well as in the anti-clockwise direction. The sequences will be taken here. Okay, and also the Twiddle factor is going to satisfy one more property which is called as a symmetry property. Let us look into the symmetry property in the next session. So thank you everyone.